Alrighty, welcome to my self-study Computer Organization and Architecture. This is based on a book written by Null and Julia Lobur. It is called The Essentials of Computer Organization and Architecture. I am focusing on Chapter 1 and almost pretty specifically around page 28, which is about the von Neumann model. And thank you for joining me, and let's jump down into the computer science rabbit hole. All right, once again, this is the von Neumann model, The Essentials of Computer Organization and Architecture by Null and Julia Lobur. Please forgive me if I butchered any of those terms and names. All right, so if you go to the book, you'll see that there is some references to what the von Neumann model consists of. And it consists of 3 hardware systems. It consists of the capacity to carry out sequential instruction processing, and it contains single path, physically or logically, between main memory and control unit. These are the minimum features, not all the features, but this is what the book references. So if you're actually reading this book and you're taking a class, you may actually need to know that. Let's go to the 3 hardware systems. So 3 hardware systems consist of the CPU, the main memory system, and the input-output system. If you go down a rabbit hole and you go to other sites, you may see some references about the bus, and even in the book you might see some references about the bus. But on page 28, the minimum features are listed as these 3 right here: the CPU, the main memory system, and the input-output system. So now if you look at the CPU, it consists of a couple other components. So this is the subcomponents. So it consists of a control unit, an ALU, registers, and a program counter. The program counter is actually part of the registers. All right, so just keep that in mind. And so this is the drawing from the book, figure 1.4. And so let's go through it again. Here's the CPU. Here's the control unit. Here's the ALU, which is the arithmetic logic unit. You'll see registers, and then you'll see it call out the program counter. You'll see the main memory system right here. And then you see the input-output system. And then you see a small drawing right here that I pulled from Geeks for Geeks. And actually like this drawing. It's really pretty much this drawing, but this drawing turned a little bit to like a 90-degree left turn rotation. So anyway, so it also consists of the same thing. So let's look at this drawing a little bit more. You also still see, it says the basic structure, the memory, the processor, input-output. So processor consists of the control unit, the ALU, and it actually calls out the accumulator here, where the other one called out the program counter, so you can see where everyone wants to call out a different feature. All right, and the input-output. So Geeks for Geeks is actually a really good site. You should check it out. It has a nice little tutorial on the von Neumann architecture. I think you will like it. But again, if you're taking a class, make sure that you know what your instructors want you to learn. And if they specifically say learn about the essentials of computer organization and architecture information from the book, make sure you keep track of what your professors are asking you for. All right, so now we're back on to the minimum features. And so now we're on capacity, which was number 2. And so capacity is the capacity to carry out sequential instruction processing. Instructions are executed one after another in a sequential manner. The process fetches instructions from memory one at a time, it executes them, and then it proceeds to the next instruction. So that's basically just kind of telling you how the process works. All right, so what's the execution cycle? So it's called the von Neumann execution cycle, but you will actually see in the book and on many sites online and during discussions, most people reference it as the fetch, decode, execute cycle. So one full iteration of the fetch, decode, execute cycle is the control unit fetches. It fetches the next program instruction from memory using the program counter to determine where the instruction is located. So the control unit uses the program counter to help it with instructions that are from main memory. All right, the instruction is decoded into a language that the ALU can understand. So we already did the fetch, now we're decoding, and that is the process so that the ALU can understand what it needs to do. Any data operands required to execute the instruction are fetched from memory and placed into the registers in the CPU. The ALU executes the instructions and places the results in the register or in the memory. And that's it. That's page 28. That's von Neumann. And let's see, what else do I need to tell you? So I'll wrap it up real quick. We looked at computer architecture, chapter 1, page 28 specifically, which is stored program machine architecture, the von Neumann model. Some of the terms and acronyms that we came across is CPU, CU, PC, IO, and ALU. So CPU is central processing unit, CU is control unit, PC is program counter, IO is input output, ALU is arithmetic logic unit. There are some really good questions at the end of the chapter. You should look at them and try to figure out, try to answer them and go down your own little rabbit hole. I did use some information from Geeks for Geeks, and remember that if you're using the book for a class, make sure you know what your instructors are asking you for. And then the first page, our lovely bunny here was made by StableDiffusionWeb.com. Thank you. Bye-bye.